For our final design project, we decided to use Rwandan coffee. For the roast, we used a medium temperature and a high fan for 7 minutes. The overall energy usage for the roast was 0.18 kilowatts per hour for all the beans we roasted, but we only used about 59.6 grams in our brew, so this calculated out to 0.11 kilowatts.
Now we'll show the process flow diagram for roasting. We put about 110 grams of green beans into the roaster and ended up with an unknown mass of chaff, an unknown mass of gas, and of course about 94 grams of roasted beans. We were even able to conserve energy by using medium heat and still producing the dark roast that we wanted. We made a second process flow diagram for brewing. We combined a total of 1,101 grams of water and 60 grams of beans using the clever. After letting it extract for 6 minutes, we got about 51 grams of evaporated water, 49 grams of spent grounds, and 939.5 grams of brewed coffee. Our brew ratio came out to about 18. Now we'll show how we got these values using mass balance equations. Due to conservation of matter, the mass of dry coffee has to equal the mass of spent grounds and solids in the brew combined. We already measured the mass of dry grounds. We estimated the mass of solids in the brew by plugging in our measured TDS and total mass of the brew. Using this formula, we determined that 10.4 grams of the grounds ended up in the brew. From there, we used simple subtraction and found that there were 49.2 grams of spent grounds. For the mass balance of water, we used a similar equation. The hot water fed into the grounds must equal the total mass of water in the brew, mass of water absorbed by the grounds, and the mass of water evaporated. Once again, we had already measured the mass of hot water, so we can just plug in that value. We can estimate the water in the brew by subtracting the mass of coffee solids from the total mass of brew. We can estimate the mass of water in the spent grounds by multiplying the absorption ratio and the mass of the dry grounds. After plugging in the numbers and doing some quick subtraction, we found that there was 890.3 grams of water in the brew, 160 grams of water in the spent grounds, and 50.7 grams of water evaporated.
Here you can see we were heating our water to 96 degrees Celsius. This used a total of 0.12 kilowatts per hour to heat all of the water we used. We were able to minimize our energy usage by heating only the amount of water we needed to make sure we didn't spend energy heating water that was just gonna be left over.
In the blind tasting, we agreed that our brew had a chocolatey flavor and a pleasant aftertaste. It was very mild and neutral and had no off-putting sour or bitter taste. It turned out to have an acidity level not too high or too low. We think this well-balanced flavor is what led us and others to enjoy our coffee. The TDS for our most efficient final design brew was 1.2, and our PE was 17.7%. With a brew ratio of about 17.5, this put us right on the line for the ideal square.
So here you can see what we were doing during the actual design competition, but if we had another competition, we would have liked to blend or mix different coffee types, such as the Rwandan with the Guatemalan, because we just preferred those over the Sumatra. We also would have used a lighter roast, and hopefully this would allow us to conserve more energy during the roasting, and we would have like to have a longer extraction time, somewhere around 7 minutes. Hopefully this would lead us to have a higher TDS, but we would like to keep our brew ratio at 17, and hopefully all of these new changes would allow us to land in the ideal brew sweet spot.